Okay, so let us begin with vibration analysis. Now, kanina pinag-usapan natin yung mga introductions for vibration analysis. Now, we have talked about degrees of freedom, yung amplitude, the phase, out of phase, the types of vibration. Now, we should input na nga kagad natin sila. Saan? In order for us to analyze yung mga vibrating elements. Okay? And we'll go through vibration analysis na. Now, ano ba yung mga kailangan nating bagay sa vibration analysis? Yun, yung mga bagay na sinabi ko kanina. Amplitude, magnitude, yung equations of linearization, the CN, okay? Complex exponential notation, yan. The phase, yung displacement, yung Euler's formula, and anything of them, everything of them. Ngayon, what is vibration analysis? Now, the input, okay? Ang tawag dun is the excitation. And then the output, ang tawag dun is the response. R, ano, WRT time. Okay, mamaya paliwanag natin yan. Response depend on initial conditions. Okay? Nipisan lang natin. Yan. So, yung response daw are or the response depend on initial conditions and external forces. Yung mga i-apply mo. Most practical systems sometimes are very complex in terms of mathematical modeling and it requires simplification first. Ano ba yung mga procedures na kailangan natin? Siyempre, pag magso-solve tayo, hindi naman tayo magso-solve kaagad. Kailangan i-consider natin kung ano yung mga parameters na given, kung if they are in single degrees of freedom na ba, or they are too complex to understand, kailangan himay-himayin muna natin sila. Now, this is the proper procedure. First, gumawa tayo ng mathematical model. Kaya nga, yung pinakita ko kanina, yung mass spring damper model, mass spring damper models, yan. Yung mga single degrees of freedom, several degrees of freedom, or multiple degrees of freedom. Number 2, yung derivation. Okay? Consider natin dyan, yung mga derivation of displacement, the acceleration, that is all with respect to time. Number 3, we solve the equations for specific boundary conditions and external forces. Kung ano lang yung given, dun lang natin siya ikukulong at dun lang natin with respect isosolve. And then, how will we interpret yung solutions? Hindi naman pwedeng na-solve natin, ito yung value. Siyempre, i-interpret natin yun na kung yung value ba yun is uh, too much, not enough, disrupting, or even yung kanyang magiging magnitude after that. And then ito, this is a good example. We have a piston and cylinder engine where this is a crankshaft, kung saan gumagalaw yung iyong engine. Okay? And this is the piston rod. And this is the piston head. Ito yung piston head. This is the cylinder. Now, yung engine mo is reciprocating. Ibig sabihin, at some point, it will go from top dead center to bottom dead center. And you have now a holding fixture dito. Okay? Siyempre, ito yung iyong mga slots. You have the bolts kung saan you will hold the machine fixed. Okay? Siyempre, kailangan maglagay ng rubber dampers in a way na parang elastic pad ang nilagay niyo dyan. And then, ito yung foundation, the machine foundation. Kung saan, itong machines na to, gumagalaw-galaw yan. Okay? Gagalaw yan. Ibig sabihin, nagbabibrate siya. And, saan dito yung pinaka makakapektuhan ng iyong vibration? Ito mga bolts na to. They may give up kung pangit ang ang iyong foundation. At yung foundation mo, since solid yan, hindi naman elastic yan, you will have your dampers here to absorb yung shock na gagawin ng machine. Ito yung iyong model, pero hindi pa yan yung iyong mathematical model. How will you make a mathematical model? Okay? You will now have to consider, magigawa ka ba ng spring? Gamit ka ba ng shock absorbers or dampers? Gamit ka ba ng spring systems? Now, the best way for you to understand kasi yung ating models is with the use of spring elements. Now, going back to your strength of materials and machine design 1, pinag-uusapan natin diyan yung springs. Now, under Hooke's law, madalas 'yan, 'di ba? Madalas yung pinag-uusapan natin sa spring. Ano ba yung sa Hooke's law, sir? That the force is equal to the ano, kx. Ano ba yung x, sir? This is the displacement, okay? Nung spring mo. X is the displacement of the spring. F is the F is the force that is applied to the spring, and then K is the spring constant. Now, sabi dito, pure spring element considered to have negligible mass and damping. Negligible ang mass and then yung damping. Force proportional to the spring deflection. Force is directly proportional to the deflection or X. Kaya lang, ginagamit natin kasi sa deflection is this one. Yung sexy. Okay? Tawag ko dyan, sexy. Now, what is the form? Ito yun. Varying and deflection. Okay? Depende sa force na i-apply mo. For linear springs, the energy stored is in terms of potential energy. Okay? Energy is equal to yung 1/2 nung spring constant, tapos, x squared. Or equal to saan? Diba? Kx to. Fx na lang yan. 1/2 ng f and x. Or the deflection. Doon yung equal. Ayun. Actual springs sometimes behave in non-linear fashion. Pwedeng ganon. Pwede ipipredict natin yan. So, we have now a mathematical equation. Okay? Pero wala pa tayong model. Important to recognize the presence and significance ng magnitude of non-linearity. And we could get the desirable amounts to generate linear estimate. Ngayon, we have x and y. Okay? X and y. Ay, baliktad pala. So, this is x. This is y. Now, in your y, that is a varying component which is force. And then x is the deflection of the spring. Now, we can predict that if the force is greatly affecting yung mass, yung spring, ibig sabihin that the graph will be exponentially growing or behaving. Kasi ang deflection mo, daan mo dyan, directly proportional. Ngayon, pag non-linear yung fashion niya, ibig sabihin kung ito yung usual, okay, usual graph, if non-linear fashion, you can predict. However, medyo mag-iiba yung iyong equation, katulad dito. Pero, mapipredict mo yung kanyang, yung kanyang trend. Na for, equivalent spring constant, okay, ano ba yung mga yon? Meron diyang given, yung cantilever beam. Yun nandun kanina, ito, tulad nito. Mass of beam assumed negligible, okay? So, hindi mo i-consider yung mass. Ayan yun. Ayan. Ito yun. Ano ba yung mga constant dito? Ang constant dyan, di nagbabago, yung area, cross-sectional area ng inyong beam, yung moment of inertia ng beam mo, kasi nakadepende yan sa sa area. And then yung E, what is E? Elastic modulus ng iyong beam. And that is given by this equation. Yung deflection niya is mgl. Ano po ba yung mgl? mg is equal to the force that is applied. mg. That is equal to the force applied dun sa iyong cantilever beam. Yan. So, L is the length of the beam cube over 3 EI. Eh, again, what is E? That is the elastic modulus of the beam. Depende sa material. Okay? E, for steel, pwede rin. Tandaan mo yun. E, for aluminum, tandaan mo rin yun. And then I, that is given by the equation, ano? Kailangan alam mo rin yan per cross-sectional area. Kung square ba siya, kung rectangular. And mostly, they are rectangular or in square. Now, for the stiffness, pwede mo ma-derive yun. Diba dito sa stiffness going back? Ito yun, no? Diba? The stiffness is K. You can derive that from F is equal to Kx. Ang stiffness is in pound per inch. So, that is K equal to F over the deflection. Where F, di ba, is equal to mg. O ngayon, pwede mo na masabi that the stiffness, okay, will be equal to, ano? Will be equal to 3EI over L cube. Na-derive ka agad yun. And then, ito yung actual system na sinasabi dyan. Okay? And then, you can translate it using mass spring damper model. Pero nagkaroon ka dito ng single degree freedom model. Wala ka nga lang damper. Okay? That is translated na. That, sabi dito, that your M will have a certain deflection. Okay? Ito yung certain deflection niya that will be counteracted nung stiffness ng iyong spring. Ayun. Ito yun. Alam nyo na? So, meron kang model, actual system, i-translate mo siya sa single degree of freedom model na kung saan pwede mo makalculate yung parameters na kailangan mo. Okay? So, now, this procedure can be applied for various geometries and boundary conditions. Meron naman tayo yung mga multiple springs. Balik tayo ng inyong strength of materials. Now, in your strength of materials, paano mangyayari kapag ang spring mo is in parallel? Okay. If this is your actual model, you have two springs of different stiffness. Yan, meron kang spring 1 and spring 2. And then one bar end kung saan meron niyang mass or force that is applied. This is actual, And then it will have a certain deflection. Depende pa yan dito sa dalawa. Okay. Now, if you have a weight here or the force na nakahanging, and then, gawin mo ito. Ngayon, yung K1 mo multiplied to multiplied to deflection, that is the force, and then force 2. Di ba ang force 1 and force 2, kapag parallel ang springs, the force total will be equal to F1 plus F2. Tama? Parallel to. Ayan. F1, F2. Eh, ang F1 mo is equal to K, tapos yung kanyang deflection, and then F2 is K2, yung kanyang deflection. That is added and will be equal to your weight. So, na-derive yan dito. Ayun. So, we can say that weight will be equal to mg. Mass nung bar mo times gravity equal to F1, that is K1 in deflection ni 1 plus K2 deflection ni 2. Yan yung kanyang spring model, mass spring model, and then kanyang mathematical representation. Okay? In general, for a certain number of springs or several number of springs or even multiple number of springs in parallel, ito yung kanyang equation. Yung summation. And so on yan, in summation. Okay? So, naintindihan ba natin? Yung deflection niya, paano ba yan? Sir, pag ang deflection ng parallel, yung total deflection niya will be equal to deflection ni 1 equal to deflection ni 2. Same yan. Okay? Paano naman, sir, kapag in series? Ayan. Ipapasok yan, ha? In series, additive ang kanyang deflection. Ang force, sir, yung force total niya will be equal to force 1 equal to force 2. Kabaliktaran naman nung parallel. Okay, ganun din naman, yan, nai-represent niya. If this is your actual model, okay, yung actual model mo, pag nagkaroon ka ng certain loading, additive or at total yung kanyang deflection. Ngayon yung force niya is, throughout the system equal. And you can represent it using mass spring model. Sa mass spring model natin, meron ang bara dito or a mass that is applied. Ngayon yung mass na yun is equal to mg. Okay. So, additive lahat yan. So, weight will be equal to F1 equal to F2. Ibig sabihin, ayan na yung kanyang representation. Okay? So, that is for the springs in series. Now, we combine the equations. Okay? We combine the equations. We will arrive with KEQ. Ano yung EQ? Equal to. Equal naman lahat. Okay? Equated. MGKE to total to. Okay? Total deflection. KEQ. Nasaan ba yung KEQ dyan? Equal naman daw sila eh. Ay additive. Okay? Equal. So, you will arrive with this. Ayan. So, na-arrive na tayo from parallel to springs in series. Now, we will have them continued. So, we substitute the equations mula dito, 'di ba? Coming from yung total mo is ganyan. Additive yung kanyang deflections. So, ito yung 1. Okay? Ito yung 2. Ayan. So, masisimplify natin siya. Okay? Cancel natin to, okay? Cancel natin to. Cancel natin to. So, nag-arrive ka ng 1 equal to KEQ plus KEQ over K1 plus K2. Kaya lang, hindi natin to pwede pagsamahin. Yan. KE1, K1, K2. The best way for us is to cross-multiply muna to. Okay? 1 equal to KEQ, K1, K2, plus KEQ, K2, K1, over K1, plus K1, K2. So, we will arrive yung ganito na. Yan. Pag sinimplify. Now, for springs in series, isinimplify din niya. Yung summations. Okay? KI. Aba yung KI, where I is the number of springs na meron ka dyan. Okay? Ayan na. Okay? So, ano yung malalaman natin dyan? So, meron pala tayo pwede nating i-apply gamit yung ating, strength of materials pagdating ng vibration. So, ang vibration kasi is a part ng ng machine design. Kailangan nga, i-consider mo yung vibrations pag mag-design ka na ng machines. Okay? And that will be all for spring models, okay? Spring elements pagdating ng vibration analysis. And we will continue this on our next meeting. That will be all for today. Have a nice day.